Hi everyone, this is David from Melbourne Flight Training. Today we will be talking about the VOR system. The VOR, or Very High Frequency Omnidirectional Range System, is a ground-based navigation system that allows you to navigate within the US National Airspace System. Some misconception that people have with the VOR system is that it will never tell you which heading you're flying. All it's going to tell you is in which direction from the VOR you're from. So today we will be talking about how does it work, what are the different volumes that it has, some errors that the system might have, and how would we actually fly it. So how does this VOR system actually work? We have this ground-based antennas that you can find mostly in airports, but they're also located sometimes in the middle of nowhere, that are sending out two different signals. So these two signals, or two phases of signals, are called the reference phase and the variable phase. Let's imagine it this way. The reference phase, imagine it as an umbrella opening. So if you do this, it's like a pulse. It's sending the signal in the 360-degree directions. While the variable phase, imagine it like a lighthouse, where it's sweeping across those 360 degrees. With this method, what we're getting is a phase shift. In this phase shift, all that is telling us is the difference between the variable phase and the reference phase. With that difference, your receiver is able to determine what radio from the VOR station you are. Now, VORs, as I said earlier, only tell you your direction from the station, but they can be aligned with other type of equipment, like a DME for a VOR DME, or with a TACAN for a VOR TAC, where it can tell you not just your direction, but also your distance. VOR volumes. Basically what VOR volumes are is the range that you can identify the signal from the VOR. So we have two different volumes, the VOR low and the VOR high. The VOR low starts at 1,000 feet, goes up to 5,000 feet first, where you can identify a VOR from 40 nautical miles, and then it will go from that's 5,000 feet to 18,000 feet, where you can identify from 70 nautical miles from this VOR station. On the other hand, we have the VOR high, where it goes from 1,000 to 5,000 feet, 40 nautical miles, from 5,000 to 14,500 feet, 70 nautical miles, from 14,500 to 18,000 feet, 100 nautical miles, from 18,000 to 45,000, 130 nautical miles, and finally, from 45,000 to 60,000 feet, again, 100 nautical miles. So how can we identify if our VOR is low or the VOR is high? You can identify it in your IFR low en route or in the chart supplement. Now we will talk about VOR errors. When flying with a VOR receiver, just because of the nature of the system, there's some errors associated with it. The first one is line of sight. Line of sight basically implies that there's something that is interrupting the signal from the antenna on the VOR receiver to our airplane. So let's say that we are flying, and between us and the VOR station there's a mountain, there's buildings, or anything that can disrupt this. Our signal may have interference and we can lose the signal for a little bit. The second one is the cone of confusion. So you can imagine a VOR receiver and its radios like a bicycle wheels hub and the spokes. The closer that you are to the VOR, those radios are all together. And as you keep getting farther out, those radios start getting separated from each other. So what does this imply to us? That as we're getting closer and closer to the VOR, especially within 1 mile of the station, you will start seeing your needle going left and right, and maybe disappearing. So whenever you're flying really close to the station, you just have to keep flying your present heading, and as you cross the station and go to the other side, that needle is going to stabilize and it's going to center again. The next one that we have is reverse sensing. So reverse sensing happens mostly on analog CDIs, where let's say we're flying to the station on the 180 radio, but instead of having it set to a 360 from, we have it set on a 1802 in our OBS. So basically what it's going to tell you is that if you get drifted from that radio because of the wind, because of wrong technique, because you get distracted, the instrument is going to tell you that you need to fly right to intercept it again. But actually, you will need to fly to the left. That is why it's really important that when you're flying to the VOR, you're flying with a to indication, and that when you're flying from the VOR, you're flying with a from indication. Lastly, the last VOR error is the area of ambiguity. This area of ambiguity is something that a lot of people don't think about or don't talk about, but it can be crucial. Why is this? Let's say that you have selected the 180 radio on your receiver, and you start flying immediately 90 degrees from this VOR station. What it's going to do is that your system is not going to be able to identify if you're to or from in your current indication. So it's going to show a flag as if you have an error or your instrument is not working. So in this case, what you need to do is the same as in the cone of confusion. Keep flying your same heading until you get out of this area of ambiguity, and the instrument will be able to tell you again if you're flying to or from the receiver. Something really important that a lot of people don't think about is that when you're trying to fly a VOR, you have to make sure that the VOR is actually working. And why am I saying this? When we talked in the GPS system video, we said that the FAA is transitioning to fly performance-based navigation with GPS, but they're still keeping some VORs available in the country. So one VOR that you may be used to flying your whole life may not be there at any given time. And there's a lot of NOTAMs where you can see that the VORs are not working. So you have to definitely identify the VOR listening to the Morse code that is displayed on your either VFR sectional chart or your IFR low end route chart. This is critical to ensure the safety of flight. So this set of VOR stations that are being kept operating in the country, it's called the VOR Minimum Operational Network, or VOR MON. This MON will ensure you that at any given time within the 48 contiguous United States, you're going to be able to find a VOR within 100 nautical miles of where you are, and you can fly the VOR to an airport that has an approach that is not based on GPS, which means a VOR or an ILS approach. Today, that's all that we'll be covering regarding VOR systems. Thank you, and please stay tuned for future videos. See ya!